I'm not the star of the show, but we want to get those guys up here. So we'll go ahead and get started. I'm Eric Tangadal. I'm the IT director for the School of Business. And I'm hosting tonight. We'll have 4 presenters, but I wanted to start off and see who can tell me what song this is. The band. You can name the band. And if you can't name the band, I know you got smartphones, so whoever can just Shazam it first and tell me what it is, there is a prize. I don't have any Alt Nation listeners here. Sirius XM, Alt Nation, very popular song. Come on. I'm surprised it's not your favorite, Alex.
I can't name that tune.
Right up here.
I'm too old.
It's Big Data. Song Dangerous. So this is your hat. Almost.
Nice.
I wanted to show the video, but it's completely inappropriate. So we won't be doing that. It's a video about a band. They're very popular. They're played a bunch on the radio. In this video, they're trying to sell these shoes that actually say Big Data on them, and they're doing a pitch to a group. So I thought I'd throw this up. This came across my Facebook the other day, and I thought it was appropriate because I wanted to ask. I've been asked about 4 or 5 times this week, what is Big Data? Define Big Data. What's it all about? John and I had the discussion. He's like, I don't think my stuff is Big Data. What is Big Data? So we've definitely probably overused the term. So I wanted to see if we could get by the hype of what it is. So I decided I'd simplify, and it helped me to go around and talk to all these presenters of what we were trying to do here. So basically now we can collect, download, stream more data than we've ever been able to before. So we've got access to incredible amounts of data. The volume and the speed that the data is being created, downloaded at, is creating a lot of new problems. I mean, you think about if it's just a huge corporation that's trying to solve a big data problem versus you just can't get in Excel anymore. All of a sudden, Notepad doesn't allow you to put all that information in Notepad. You've got big data problems, and you've got to find a new solution, whether you're going to use a new tool out there, a new application to try to solve what's going on with that. And finally, we have access to computing power that's allowing us to sort through this data to be able to find the relevant information, be able to find what's important to our company, what's important to security, what's important to the problem we're trying to solve. So one of the things with that you can think of is the cost to entering this is way cheaper. And the gentleman that gave the big data, John Wagner, talked about Dan Wagner, yeah. I got them, the two of them mixed together, okay. Talked about how cheap it is now to get an instance spinning up on Amazon Web Services that gives you access to completely scalable computing resources for probably maxing out your credit card in college, where before it would have been hundreds of thousands, if not millions of dollars to get access to that computing power. So now, as small businesses and individuals and entrepreneurs, we've got the ability to solve problems that we could never solve before. So what we've done tonight is we wanted to showcase some of the things that are going on campus, these people that are solving new problems, the tools they're using to do it, and how they're going about it. So like I said, I'm not the star of the show. We've got some people doing some amazing stuff on campus, highlighting the research, the students, the classes that are going on. First of all, we'll have, what I really like is the involvement that the representatives of Montana, and we are very honored to have Mayor Engen here to start us off with a presentation, to be followed by a few of the other Montana representatives have come with a statement as well. And then following that, we'll go through these presentations, of which I'll introduce each one of the individuals, give them a chance to get their presentation set up and get going. but I'll introduce each one and kind of talk about what's going on in terms of classes and research across campus. And then finally, I hope that all of you can join us on the second floor in the Guyanchetta Piazza for a reception following this. So with that, Mayor Engen.
Thank you very much, Eric. I hope to have a piazza named for me someday.
You should have a piazza.
What do you have to, yeah? Well, there are a few things named for me already. It's not good, however. Well, thank you very much, Eric. Thanks. I'll be mercifully brief because you're all smarter than me and you have more things to learn. But I will tell you that we're excited about Big Data Week, and we're certainly excited here in Missoula about the Big Data Alliance, simply because, as Eric suggested, we have folks from a lot of sectors now coming together to solve problems. And not only do problems get solved, but in many cases that problem solving involves smart people working together and commerce ensues. So we're solving problems and somebody might be making a buck or two, and we might have a good job and someone who can be a fully realized citizen in our community as a product of all of that activity. And I don't think it gets much better than that. So I'm glad that you're all here participating, and I'm glad that we're in good company here. During Big Data Week, we've got, Councilwoman Koppel was telling me we're in the company of Zurich and Chicago and some part of East Missoula is my understanding as well. So it's spread all around, ladies and gentlemen. So we celebrate this evening Big Data and all that that means, but it doesn't mean much without people. So I'm glad people are here to make it happen. Thank you very much. I am here in person. Apparently senators and representatives couldn't be bothered, but is that correct?
Apparently.
Yes.
Yeah.
So representing Senator Tester this evening, my friend Deb Franson. I'm just teasing. John Dolby.
All right. Gee, John. Senator Tester is sorry he can't be here this evening. He is back in Washington. And he asked me to bring this message regarding big data. Thank you very much for inviting me to share a few words, and thank you to the University of Montana, the Missoula City Council, Missoula Economic Partnership, Montana Associated Technology Roundtables, and all the other partners here today for making this week possible. Every day we see the growth of information technology in our communities and around the world. And as our economy continues to grow, Montana must support our high-tech businesses and startups that improve how we share information while still protecting folks' privacy. That's why in one of my 14 small business opportunity workshops, I brought national high-tech leaders together to network and share ideas with Montana business owners. That's why I also work to bring Blackstone Group to Montana to work with MSU and UM and support Montana's entrepreneurs in all industries, including high-tech startups. And that's why I'm the sponsor of the Freedom Act, which strengthens privacy and limits the government's access to the personal information of law-abiding Americans. Because being a global economic leader should not come at the cost of our most basic freedoms. Thanks again, and good luck, Senator John Tester.
I'm Marie Porter, and I'm here from Senator Walsh's office. He also could not make it today. He's back in D.C. And he sent me with a message. Friends, I want to thank the University of Montana for hosting today's event in conjunction with Big Data Week. The telecommunications industry is steadily becoming a larger piece of Montana's economy. As business around the country appreciate the quality of life we have found here in Montana and identify the qualified high-tech workforce we have to offer, we can expect to see IT firms locate here. The University of Montana is helping to develop Montana's tech-based economy through its Big Data Science Initiative, while the School of Business is expanding its big data offerings to ensure that graduates are prepared to meet industry needs wherever they work. I'm excited that many graduate-turned entrepreneurs are choosing to start their businesses right here in Montana. However, we must work together with groups like Missoula Economic Partnership and Bitterroot Economic Development to make sure we are expanding or enhancing IT infrastructure throughout the state. There are still too many Montana communities that do not have the necessary tech equipment. And as more high-tech industry relocates to Montana, we must make sure we have the predictable environment and the infrastructure necessary to be successful. As a member of both the agriculture, and commerce committees, which oversee the telecommunications industries, I will work to ensure the communities in Montana have the access to high-speed broadband. After all, we are going to ask top businesses to locate here. We need to ensure they have access to top infrastructure. I look forward to working with you, and keep up the great work. Sincerely, John Walsh.
My name's Dan Stusik from Congressman Daines' Missoula office. It's great to see so many familiar faces here, and I certainly know that Congressman Daines would much rather be here than back in D.C., and contrary to popular belief, they still often do make it back there during the week. So I'd like to read a letter on the Congressman's behalf. Dear friends, this weekend event is a wonderful opportunity for the University of Montana as Missoula joins cities from around the world in realizing the importance of big data and technology in economic and academic growth during Big Data Week. Technology is able to remove geography as a barrier to economic growth and allow Missoula students and businesses to compete with others across the world. We certainly understand the quality of life here in Western Montana, and through collaboration between the University of Montana and the tech business community are able to train and keep our talented students in state. They certainly are our future and our most valuable resources. My recent discussions with many leaders in the Missoula technology, big data business sector and the University of Montana, as well as a tour of the new Cyber Lab, assured me this burgeoning industry is in good hands. As a former businessman with Right Now Technologies and member of the Subcommittee on Cyber Security and Infrastructure Protection, I certainly appreciate your interest and work in this sector and look forward to continue seeing tangible results. I agree with Mr. Tangoodall said, anybody in business knows the importance of relational databases. This is about looking instead at real-time analytics. How do we understand and use data at the point when it's actually being produced? That is a question with applications across industries. Students here are exposed to very good cutting-edge content and curriculum and learn a skill that's highly employable in today's environment. As Montanans, there are many reasons businesses prefer to hire local professional graduates who want to continue working in the community and state we all know and love. Thank you all so much for your attendance and participation. Sincerely, CPAs. Thanks.
So Russell and Sam, I'll let you guys come down and start getting set up here. So as they get set up, I kind of wanted to emphasize a class each time we had somebody up presenting, and we do have Brian Steele in the back here that's been a huge part of the big data initiatives from the math department. He's the professor that these guys worked on in the class called Big Data Projects, and that's what these guys worked on, and this is what came out of the class. So there's a lot of effort going on in a lot of different areas on campus, and I just want to make a point of that.
We were definitely just one group of many in this class, and our problem was looking at pain, and mainly how pain affects participation with people with disabilities in the Missoula area. He's Russell, I'm Sam, and today that's essentially what we have a clear.
Yeah, right on the other side.
Thank you.
Cool.
There we go. That's going to be easier. We've got a laser pointer now too.
Oh, nice.
There we
Perfect.
go.
So yeah, today we're going to be kind of trying to tease out what effects, if any, does pain have on your level of participation? And also, to begin with, we're going to give you a brief overview of what big data is. And then we're going to go and talk about the data set that we use that was given to us through the ecological momentary assessment, the EMA data. And then we're going to talk about the next steps. Those next three, the linear analysis, the turnoff faces, the PCA, and pain levels, along with the WECA toolkit, are all kind of tools we kind of use to explore this data set and try to tease out some interpretations, kind of what pain does to people and how it affects them. And then we'll talk about the conclusions and what's left undone and what can be done with this data. So first, Russ is going to talk about kind of...
So I think Eric did a good job of sort of giving a very high overview of what big data is. For us, we like to think of it as this data sets that are too large or complex to manipulate or interrogate with standard methods or tools. And there's a question as to why are we talking about it today as opposed to 5 years ago or any other point in history. And it's that we're now at a point in technology that we actually have the ability to assemble data sets that are that large that we can't actually process them with standard workstations anymore. And so this is a very important concept, and obviously this is an emerging field. I think that's why we have so many political representatives here today to explore this. And so this is really wonderful. And so some examples of it are the stock data. So for instance, this is about a month of Google stock data. I'm sorry, Sam, this is your...
Go for it.
Okay. At any rate, this is about a month of Google data, and if you can see there's about 7 columns here. There's actually 7. And that would be 7 dimensions of the data, but this doesn't include like trends over time or anything else. And so you can imagine this data set becomes much more complex dimensionally over time if you include other factors. And this is, again, just roughly 1 month of day-to-day prices, and this is one stock. Imagine applying this across all markets and, you know, at an hourly rate or a minute rate. It becomes a very big challenge. There's another example at this Sloan Digital Skies survey. Do you want to talk about that?
Yeah, sure.
Yeah.
So astronomical data is another example where big data is starting to come into play. The Sloan Digital Skies Survey, which is a telescope that was built in, I think, Arizona, New Mexico, sorry, yeah, in 2000, it collected more data within the first week of its operation than was ever collected before that time in the history of astronomy. So we have this problem of just a huge amount of data that's being collected, or we're able to collect all this data, we're able to process it, we just don't quite know how yet is kind of more of where the problem's coming from. And then we have some sensor streams data that Russell's got.
Yeah, for instance, the new 787 Dreamliner, I'm sure everyone's heard about it, it collects about a half a terabyte or about 500 gigabytes of data in a 6-hour flight. And for perspective, about 1 hour of HD video with the audio track is about a gigabyte. So that's about 500 hours of video, which is days and days of video in just one airline flight. Another example is this point of sale data, which is, you know, think about your like Safeway club card or something. That's a unique identifier. It's your phone number. And that says that you bought these items at this store and when. And then imagine everyone, you know, purchasing these things together. That pulls into this enormous data set that builds very quickly, especially when there's 24-hour stores. There we go. I think this is it.
So this comes onto our data set. Our data is the EMA data. It is big data. It's not big data in the sense of we're looking at terabytes. You know, we're not looking at these huge amounts of data. We're not looking at the terabytes. We're not looking at gigabytes of data. But we are looking at huge dimensionality. So first, let me give you a quick overview of what the EM data kind of came from. It first was a mass survey sent out to Missoula households, 10,000 of them to be exact. And then from this survey, if they answered yes to one of the 6 disability screeners, these disabilities were like, do you need a wheelchair? Do you have back problems? Something like that. If they answered that, and then also sent back a postcard and said that they're willing to participate in further studies, they were given into the subset. And from the subset, there was 149 of these people that were later reduced down to 123 participants in our survey because of age discrimination, because we didn't want people over 65, especially when you're looking at participation.
One second. Yeah. This is actually a screenshot of what our data set looks like if you display it in a text editor. You can see this incredible dimensionality to it and the number of rows that you can't even see individual numbers at this point. This is literally what we can see on our screen with somewhat better resolution.
Yes. So then, once we got down to these 123 candidates, what they were trained to do is use a mobile device like this. This is actually a Samsung Galaxy that was kind of manipulated just to come up with a questionnaire 6 times a day. Roughly every 2 hours, it was a little bit more or less because it was randomized for a 2-week period, where they had to answer questions such as, how much pain are you in? How well did you sleep? What kind of barriers are you facing? Are you not wanting to go outside because the smog is too bad? Or something, you know, questions as that. Along with, they had to answer a preliminary questionnaire asking about demographic, like how old are you employed? How much of access to transportation do you have? And from this, we finally got our the whole data set of 123 rows, which are all the participants, that had 4,861 columns, which are kind of all the questions, the demographics, and every time they answered a question with the cell phone device, which led to a total data points of about 600,000. This is a huge problem when you're trying to tease out what affects what, because you have 600,000 points where somebody could have answered at any given time. And so it's not very clear, so we needed to reduce the row form down somehow. Want to talk about the...
Yeah. So going back to our definition, it's really about the high dimensional complexity of our data that makes it a big data problem, not necessarily that it's in the gigabytes and terabytes, but it's that there's so many dimensions that you can consider across this. And so this image over here, we see that there's a idea that you could have 10 positions in this row, sort of like the numbers 1 through 10. But then if you have a 2D system like that, you'd have 100 positions you could answer. You turn it into 3D, you'd have 1,000 positions. This is called the curse of dimensionality, and it's common in computer science and statistics. And so our data set applies to this sort of idea of big data because of the dimensionality of the problem, which makes it difficult to apply traditional analysis techniques to it directly. And so a lot of our time was spent subsetting our data out and devising new data sets to perform our analysis, so we didn't have to load the entire data set into memory. We'd be able to load just a specific portion of it that answers specific questions while we were looking at it.
So, to start, just to reiterate what our goal was, is to investigate the relationship between pain and participation. The problem is our data set did not have a specific thing that says, are you participating? It had tons of demographic information, tons of times that they had to answer question, but these are people with disabilities. We didn't have something for participation. It's hard to say that if you're shopping, you could be participating because you have a severe disability. So the best proxy that we could use is whether you're home or away. If you were at home, you weren't participating. If you're away, you are participating. Not a perfect measure. You could be at home working, and under our data set, you would be considered not participating. But it's kind of the best we got, unfortunately. So we used that as our proxy measure. There we go. And then, again, our problem is dimensionality. We have these 6 times a day. We need to divide that down somehow. We can't just have 4,000 rows and trying to figure out what relationship each thing has, because you're going to have a million of just single points at each one. So the first thing that we did was to do a simple linear regression where we collapsed the six time periods down to 1 and looked at the participation variable as a ratio of if you're home or away. So you got a score of 1 if you're away, you got a 0 if you're home, and this led to a ratio. So the higher the score is, the more time that you were away, the more time that we're considering that you're participating. And then part of the demographics variables was this pain variable, where they rated 0 to 10. A 10 is you're in excruciating amount of pain, a 0 is you're in no pain at all. Perform some linear analysis on this home away variable with pain, multi-day kind of time series data. But the thing is pain seemed very unrelated doing this. We found no correlation between pain and participation, or pain and being home or away. And that's kind of confusing because we assumed that there was. Furthermore, we found that if you were home or away did relate to whether you're employed. It also related if you had access to transportation. And all these things kind of made sense. So whether you're home or away and just pain had no relationship, the R-squared score was basically 0. But if you factored in all these other demographic variables, like the ones I just said and a couple others, you got an R-squared score at about 30 or 0.3 or 30% of the relationship was explained. So this doesn't work. I mean, it's just not. Oh, yeah, no, you're fine. So that wasn't good enough. I mean, our guess is maybe pain and participation. Pain is such a quick moving measure that you can't just look at it as like a daily thing. Is how much pain are you in today? Maybe it does matter how much pain you are in these 2 hours. Maybe if you're in a ton of pain right now, maybe by 5 o'clock this evening, you won't be in any pain and you will go out and you will go participate. So the next thing is to do a logistic regression model, which is saying that you get a 1, it's a 0 or 1. We're going back to the 6 variables, but we're just looking at pain versus these 6 time variables is how much pain are you in right now versus whether you are home or away during that time period, and using time period before and time period after. Unfortunately, the same thing happened. There was no correlation between whether you are home or away and how much pain you currently are in, or whether you're home or away and how much pain you were in or in the future. So, I don't know, pain just did not seem significant with a person's participation level. So this begs the question of, we don't quite know. We came in with this strong hypothesis that pain and participation are strongly linked. This is what the psychologist Craig wanted us to look at, and we thought pretty strongly that it was going to work. So our next thing was to say, well, maybe we should look at how pain changes through the day and kind of get some ideas of where to proceed, because right now we're kind of stumped. Oh, perfect. So this one is, this is just looking at pain and how it changes throughout the day. What we have here is the starting pain level is this down here. It's actually an intercept. So you see over here the 0 point. Oops, that's not good. 4.2, thank you. Doesn't make any sense that people are in negative pain, but these are intercepts, so it means that they started off in very little pain, and then got into more pain later on, is the only way how that works. So it's not a perfect measure, but it's just trying to tease out to see if there's some relationship with this, with pain and how it proceeds through the day, along with people. So each one of these dots is one of the 123 individuals per a day, per one of those 2 weeks periods. So that's, but it looks like there might be a slight negative trend, except for you look at the idea that if you start in high pain, it's most likely going to go downhill from there. If you start in low pain, you're going to go up. So there's really no correlation. You can't really say what's going on with pain. We're still back to the drawing board. And this is where Russell looks into the Chernoff faces.
So, Chernoff faces were developed by Hermann Chernoff in 1973 as a way of presenting multidimensional data in an easy way to be understood by human beings. And so humans are very good at processing faces. I'm sure all of you can see these faces, and the guy with the broken leg looks the saddest. That makes sense. It has some sort of rationality to it. Is there a way that we can take our data set and turn it into a representation of a face such that we can understand it? And that was the idea that we really pursued as an idea of how do we explore a data set that is not producing answers that are expected. And when we apply it, we get these faces here. And this was developed in the APL pack, which is a free open source language. And you can see that this guy looks really sad. But color is actually randomly generated, so it has nothing to do with it. So if we look at what our data set was to generate this, we have our row, our location, pain level, and so on. This face just looks different and looks like this face because they were home. That's all that face really represents, is that person was home today. And so this becomes difficult for how do you process these faces? Do we have any predictive capability from our data set to interrogate how your pain level is now to how it's going to be in the future? Can we produce some sort of predictive measure for it? And unfortunately, we were unable to with the turn-on faces. That there's not a good way, and maybe it's the resolution of our data, but we weren't able to get the faces to tell a story, as it were, and that caused some problems. And so what we did after that is we looked at principal components analysis. So this is a principal components analysis of basically a lot of pane dimensions. There's about 6 dimensions shoved into here, and principal components analysis, or PCA, seeks to find the axes of greatest variation within the data and creates them from the existing dimensions in the data and reduces them down. So this is a high dimensional data set that's been reduced to 2 dimensions. And we have this wonderful structure in it. We have this sort of column nature as well as these rows. So what do those things mean? And that you're not told this story automatically through exploring the data. So if we colorize the data by pane level, we get this, which is remarkable. This is actually the lowest pane. I ran out of colors and I didn't know what was better than green, so I put a 1 as that. Salmon, if you all are curious. So at any rate, we actually have 1, 2, 3, up to 10. And so we actually get this really good colorization of data points by pane level. But we still can't explain this sort of horizontal striping. And if we explore this same PCA, except in the 3 principal components rather than 2, we get these. They look better on the computer, I promise. So you can see how the data doesn't have mixed points. There's not something covering something else up. They're all very well segregated. And yet, this doesn't really make it clear why there's that horizontal row nature to it. And we've tried a number of things for it, but we weren't able to definitively answer what those rows mean. Sorry, I got ahead of myself here. So what we did at that point is that we applied we sent our data through the WCAT processing, or the WCAT toolkit, which is a free open source software that is a collection of machine learning algorithms that can take your data and basically perform predictions. And this allows researchers to interrogate data sets with machine learning algorithms very quickly without having to develop their own algorithms. And when we applied specifically a k-nearest neighbor algorithm, which is a sort of lazy classification system, we got about 70% of our data to be classified accurately. However, when we explored our data a little bit more, about 84% of our data fell into 2 of the 4 classes, and so the tool is really just predicting those 2 classes and getting it right most of the time, which there's some sort of structural bias in the data that we hadn't been able to correct for as of yet. And that really brings us to the conclusions that we were able to find from this data set at this point in time. Skip past things here. Should I just not print it? Oh, there we go. Okay. So there is a hidden structure in the PCA, and we're able to see that. It's clearly there without us being able to understand what it is. There is something that's worth investigating in that data set. And we're able to determine that your current location, either in a day-to-day prediction or in an intraday prediction, isn't able to predict your pain level in the future, which is another interesting thing. You would assume that you're out hiking and you're going to feel sore later or something along those lines, but we don't see it from the data we have. So the future direction is to apply more machine learning approaches and correct for the bias by equalizing the sort of class representation in the data, as well as I think it's reasonable to assume that you can predict a future pain level off of existing information. That we have an intuitive understanding that if I do, say, intensive labor or something, that you'll be sore later. So there should be some sort of predictive nature to it without, and we're not able to find that now as of yet, but it seems intuitive that it should be there and merits further investigation. We'd like to thank Brian and Craig for producing the data, as well as their amount of support and wisdom in this
Endeavor that we were.
Thank you. And at that, we'll open it up to questions. Yeah?
Did you define pain to the people who were a part of the survey? Because, I'm just wondering,
I can't speak to that directly. They had a sliding scale on their smartphone thing that actually you had the choice of 0 through 10 for your pain level.
And we were told that they were all prepped, this is what this means, this is what the 0 means, this is what 1 means.
All right,
so
I'm just wondering, if there's there could be someone who is, assuming they're in pain, maybe they're just fatigued and don't
Well, fatigue is actually one of the, I mean, we didn't mention it, but fatigue is actually one of the questions that they're also asked is, are you fatigued? Are you stressed? Are you depressed? Yeah, so.
And there's other data that supports that if you're familiar with, like if you cook a lot, you might get burned. And so you're more comfortable with low-level burns, and so you perceive them as a lower pain. So there's that affects your perception of pain, as well as how much you catastrophize the pain you're in. Is it really as bad as you think it is? And so that makes this a very subjective data set, that these are all 123 different individuals, and yet they're reporting pain levels as though it was a sort of strict scale that's well defined. And it's very subjective, and so it's difficult to interpret, is this pain level of 3 the same as that person's that's at 5 or something? And you can't, it's difficult to make that comparison.
In your, as you kind of move through different methods and techniques, and I thought that was super interesting and really good work, by the way. And I think it's also nice to actually try to test the hypotheses versus sitting around and proving them. There's a big difference. And you got into machine learning. There's been a lot of work recently that's available out of other institutions as well as this in going into advanced neural networks and sort of some stuff out of Stanford and deep belief networks and things. In other work we're doing, we're taking data sets where we have to go through all these manipulations to get it into a certain form to even look at patterns and trends and the things that you're wondering about now. Any thoughts about trying to use a deep belief network or a neural net logic to see how things
specifically
are...
to a neural network?
Yeah.
Our records might counter-train so that you could have one record of this person having a pain level at n, and the same record as a pain level of n+1. And so if our class system is your pain level, we could end up with the same sort of dimensional information producing different pain levels, and in neural networks that will train it so that you see all these records and you train positively, but then you see the same record and it needs to train negatively, and so you get a very confused network, which is why we chose a K-Napier algorithm for this,
Okay.
is that it was statistical rather than sort of through history.
Okay, so then going back then, what I'm still a little confused about, what were you really trying to find here? A correlation between pain and activity?
Yes.
That was the original thing, but then we couldn't find any correlation between pain and activity.
Okay.
So
once that test was over, at least in terms of a correlation.
I mean, the hope, always the hope was that it wouldn't be over, but it kind of was over.
Well, it's suspended for now. I mean, we don't have to make a determination.
So then what
anymore.
ended up happening is, what leads to these pain? Like, why are these people in pain? Like, can we predict this? I mean, that was always, the goal number one is can we predict pain? Can we help people predict pain to tell them, like, maybe you should go home now, you're gonna be in a lot of pain. We just weren't.
So one of the ideas with the turn-off faces is if we are able to tell a story that's easy for humans to read with it, that we could easily modify that smartphone app so you answer your questions, and then you see a smiley face that says either you're good to go or that you should stay home or something along those lines. And it's about predicting future pain levels off of existing information. And it's surprising that it's not an obvious connection between the data that we have and what your future pain levels are. And it's actually a really unexpected finding in this.
It's pretty counterintuitive.
Exactly, yeah.
Thank you.
Yeah.
You didn't do the study, correct?
No,
You just used the data.
yes, we just worked on the data set.
In going through this, did you come up with what you think would be additional questions that could help define this question better? That's always the goal, is to, what aren't we asking?
Personally, I was focused on just the programmatic side, so I ended up not thinking about that much. Sam?
I mean, let's think about that. I had to think about this for a little bit. It definitely seemed like there were some questions when we were going through it that might have been asked a little bit better. I mean, the clear example of that would have been just a simple question. It would have been very subjective, but are you participating? For us, that would have been a very, very easy question. And if that one was asked, that one would have helped us out a little bit more too, because our proxy measure, I don't think was the best. Personally.
I'm thinking back to like the hospitals, and readmittance is a big problem. And so they asked a whole bunch of questions, couldn't get any definition, kept asking questions. And they kept modifying it until they ended up figuring out that one of the biggest predictors was whether or not the patient had to care for somebody when they went back home. So you just keep digging for new questions, and eventually they'll come through.
And the truth is actually we do have that on here, and maybe if we had a little bit more time, we had only a semester to parse this data. If we had the summer too, we probably could parse out some more stuff. We would start exploring those lesser known channels like that and trying to see if that leads us to anywhere. So
There's an answer in there somewhere.
yeah, well that was the idea between the PCA stuff, is there's an answer in here somewhere. And then that was part of our test, is just going through like just random things and seeing, does this explain anything? No. Does this explain anything? So, yeah.
I guess it's not another question, but thinking about your question more, is that we had randomly spaced intervals that were between 2 and 4 hours, and having more regular intervals, as well as more of them, might have told a more complete story, but that's not another question, I guess. Did you?
Did you have fun?
Yeah.
Oh, yeah.
Yeah.
Well, excellent job, guys. Thank you. Joel?
Nice job, guys.
So I was excited to have Dr. Joel Henry participate, because Joel was actually my outside thesis advisor for my master's degree. I decided that I jumped into something entirely too complex in terms of computer and computer science, and I'd better find somebody on my side that knew more than I did. So he was a great help then. And this summer, Joel's going to be teaching a class about, I believe, about the topic you're talking about too, isn't it, Joel?
Yes, it is, yeah.
So, and it's open to both, it's basically looking at e-discovery of law data and how that applies, basically a big data problem with that. But this class will be open to law students and to business students, and I think anybody on campus that wants to take it. But another example of a class where we're exploring big data in terms of another field of study on campus. So we'll let these guys get set up.
Well, good evening. Thank you very much, all of you, for taking time out of your schedule to come to this event. When I sat down to put this presentation together, the word that came to my mind was fun. Let's make it fun. So fun, I think, is lots of pictures and maybe a video. So that's what I put in. If you're looking for math formulas, I have a couple. If you're looking for an algorithm, I have one. But mostly it's video, audio, and some photographs, and to make it kind of a fun presentation. So I'm going to start by just again talking about our digital world. And I'm going to throw out a few pieces of information that might startle you. So our digital world includes these phones, and I don't know that a high school or college student could exist anymore without this pose. And I know in my class, when I see one look down at their crotch and laugh, they got a phone there, or at least I hope they have a phone there. These things are the biggest data spewers in the history of man, right? When you walk down the street with this thing turned on, you're just letting data out, just like the Geico motorcycle man, who has dollar bills flying out behind him. Okay? For example, if you get in your car and drive from here to Billings and have your phone on, it's going to ping every tower all the way there. Even more startling is if you walk down Main Street with this on, you're going to connect to all the different wireless networks as you go along. Now, you can't get into them because they're probably locked, but you should probably know that your MAC address, the unique address of your hardware, goes there, as well as a list of every wireless network you've connected with that's still in your favorites list on here. Okay? So you're giving away, we are giving away a lot of data. You'll notice mine's turned off at this time. Okay? And we all do this all the time too, right? We take our computers and we connect to each other. We ask to be connected. And again, we give out all kinds of data. How about this picture? It's not the lights that is of interest, right? It's the little tiny camera up there at the top. So you're not giving out any data, but it's sure collecting it, right? Day after day after day. And towers, we're giving away, or having data taken from us by towers when we make phone calls. Just from a legal standpoint, of course, are there any other lawyers here? You know that, when you make a phone call, the number you called and the number you're calling from is not protected, right? You don't need a search warrant. You can just get it. And of course, the node, the wireless node, that's collecting, as I mentioned, data. And when you just go down to the store, right, and buy something, use your credit card, or even if you don't, can I have your zip code? How many of us just go ahead and say yes to that? Now do people look at us and we say, what the hell do you need my zip code for? They look at you like, what's wrong with you? You must be a criminal, right? And where does all that data go? Well, we have lots of big servers that this data goes and sits into, and sits there for a long, long period of time. So now we're going to try the video, so hold your breath, right? I've only got 2 doctorates, so I don't know if this will work or not.
Don't change the input here to CD. Oh, you've got it.
I think it's, we'll see. Bear with me, this is kind of interesting, but I want you to think about the data spewing out of the devices and what information she's given out as she goes along. There's no noise yet. Hang with me.
You have 2 appointments today and 1 important date alert. Consult your diary for further information. Have a nice day.
Take me to the dock, says a ship without a name that is sailing to the middle of the sea.
So, what's on today? Oh, Julie's birthday, better Skype her. No, better leave her to sleep. Oh, that new Kevin Spacey production's on at the Old Vic. And Rihanna's big tour kicks off at Twickenham. Ah, brilliant. Joy Smart Shopper event starts today. Yep, it's going to be a good day today. Right, and now I should be plenty. Oh dear, looks a bit busy out there. Let me sync my phone. Okay, that route makes sense. And a coffee will go down nicely. Joy, here I come. Green is big in Tokyo, but it's red in London.
Don't know what it feels about, but I like it somehow. And you try to make it
Shimmy, shimmy, shimmy. That's nice. That's quite nice. Not sure about the colour on that. Yes, love this coat. Well, I like it. Let's see what my friends think. Instagram. Oh, here we go. Thanks. Oh, cheeky. But you know what? I agree. I'm gonna buy it. Time to pay. Which till is free?
Okay, so the purpose of that was to see all kinds of the fun, cool things you can do with big data. I don't know, I don't think when I buy a shirt, I'd put it on Instagram and wait for my friends to tell me about it, but some people probably would like that. The idea of not waiting in line to check out, that's pretty good too. So there are ways that big data can be less than creepy. On the other hand, everything that she went through provides data, and data can be stored in these enormous server farms. Of course, we know Google has them floating on ships, right? For legal reasons. Yep. And if you take the data and start looking through it file by file, it starts looking like that. And if you start opening the files, it starts looking like that. There are just mountains and mountains of free text data, among many other kinds of data as well. And it's this free-form text data that I'm interested in. I want to be able to find information, useful information in this free-form text data. So what am I doing with textual data? The first thing I want to do is organize it by what it means, not by the keywords in it. All of you can go on Outlook or go on your Windows computer and type in a word and go find it. And it'll find documents that have that word in it. It'll find emails with those words in it. I'm interested in finding it by meaning. I'm also interested in finding it visually, not by just yet another boring table, unless the user really wants it. I think there's great power in our ability to provide visualization of the data. To be able to look through it and pick things you want and find relationships between it visually. We just really like that. Okay. One of the newest legal research companies coming out called Ravel, that's completely what they do, is provide the ability visually to find research data. I want to find by the meaning first and by the specific text second, and I want to help the user but not replace the user. Okay? And I want to extrapolate. If the user does something or several somethings, I want to extrapolate that into the data, but not use some fancy algorithm so much as I want to be able to use user guidance. Okay? So what I'm not doing is parsing through algorithm books and mathematical research and picking out things that look like that. Because that's pretty hard to explain, and it's pretty hard to tweak. Now that's not to say there's not some research that's needed and that I don't need some of that. I also need some of this, right? But that's also hard to explain and hard to change. And once you implement those things, you're very reluctant to change them. I'm in a field where you try something, if it doesn't work, you better be able to change it very, very quickly. Or somebody else will and you'll be behind. How do we search textual data today? I would say we do it very poorly. I'll give you an example. This morning I went online knowing that my youngest son is in Miami supporting a human rights event. So I started searching Google because I didn't know where it was. I couldn't find it with Google because I didn't type in the word forum. I tried convention, I tried meeting, I tried conference, I couldn't find it. Those things have similar meanings. When I typed in forum, I found it. So we just don't do a very good job. So when we start out, we kind of have our eyes closed and we kind of start looking around, and in the end, we often look like that. Okay? Now, that's not to say Google is bad. It's certainly not. We all use it all the time, but we could do better. What I want to do is take that person and turn them into that person. Okay? I don't want a piece of software that's magic. Type in your stuff, press a button, out comes the silver bullet. Okay, so the idea came to me one day when I was in an airport, and I looked out and I saw a 747 coming down, to go to the terminal. And the window looked to me to be that big. And inside it, there was a human head that was even smaller than that, and controlling this enormous big airplane. And it seems to me that's the solution. Make a super user instead of making a silver bullet. Let me explain to you further why I think that's the case. If we have that big mountain of data like that, and what we want to be able to find in it is the evidence, not some evidence, but the evidence, right? My experience is that you go through this big pile of data and you find 2 or 3 or 4 things the case turns on. Everything else is just, I'm trying this, and what in the end the jury goes for are just a handful of things that make the most sense or make the most impact on the case. Because I want to find those few things for that reason. Let's not kid ourselves, right? Lawyers are not public servants in a way, right? We do some pro bono work, but we don't do it for all this for free. So let me give you another example. I'm going to challenge you. What does that sentence mean? Who's a runner in here? Who got up today and went running? Somebody must have. We're not all sloths, are we? No runners?
We're all techies.
Used to be.
Okay.
Not there.
So that could mean that you actually ran. But it could mean a lot of other things, right? Anybody been to Vegas lately? That sentence has a new meaning for you probably, right? Okay. So here's my solution strategy, is to look at the text and capture what it means by what's around it. Okay? I think it's very hard to solve this natural language text analysis, right? How many of us have gotten an email or even a message on our phone and say to ourselves, what the hell did that mean, right? I know I have. Or I've written an email to somebody and turns out they didn't understand it the way I wrote it. Okay, we all have that. If you sit down to read a book, you don't just go to page 72 and read a sentence, right? You have to read what's around it to understand it, okay? So the challenge then is to take what's around the text and figure out what it means, okay? So how do we do that? If I give you a big mass of documents, free-form text, and by free-form I mean it could be a text message, it could be an email, it could be a document, it could be attachment to a document, it could even be, I could take an image off your phone and start looking through it to see what kinds of messages and information is there. And I want to pull from it all the meaningful phrases and sentences. And then I want to take those and put them together. But it's not up to me to put them together. It's up to the user to put them together to find what's meaningful to them. That's the kind of software that I'm working on. That's the kind of big data problem I want to find. Okay? And if I can start out by classifying the text into categories, into classifications, and let the user start picking the ones that mean the most to them, they can very quickly begin to find the data they're looking for. Okay? Software should make us better. It should make us either stronger, faster, more accurate, better at what we do. For example, unloading a ship, right? We have these big cranes that unload ships. Or drawing a graph from data in a spreadsheet. That's pretty nice, right? I mean, when's the last time any of us actually sat down and took a pencil and paper and drew a graph? Line graph? I haven't done it since elementary school, and for me, that's a long time ago, okay? And it will well, the spell checking didn't seem to work so well, but I can fix that, okay? So, given what we want in the text is hidden by what we see, can you find what's important in there? I'm colorblind, so this was especially challenging to me. Does everybody see what's in there? I think it's right here. Now, I don't know about you, but that would be important to me to find that, right? Okay. So what about text? I'll give you a few minutes, see if you can find anything meaningful in there. Okay. Well, I think the solution is finding the pieces that you want and finding how they relate to each other so you can find what it is you're actually after in the end. Okay? So if we did have a case that had to do with a contract and some shipping costs, and then I just used the word deceit. Right? So maybe we said something like, we'll promise them something, or they think we mean X. That's the piece we want. Okay? And I think you can find that. If you just did a keyword search on contract or Costco contract, you get that big circle. Okay? The way to think of keyword searches are that you have this big blob, this big rectangular blob of data, and a keyword search just slices across it and gives it all back to you. What I want to do is find the places where they all come together. Okay? So our solution strategy looks like this. You start out with what your needs are. You apply some computational linguistics and entropy, and then you use analytics to tell you whether you've done it right. It should give you feedback on what you did. And that should solve your problem. Now, the reason this thing is so large is that the solution method that we use takes a lot of computational horsepower. So you have to be smart enough to figure out how to use 8 processors or 16 processors or 32 processors at the same time. Nowadays, fortunately, it's cheap to get 32 processors. It's not cheap to figure out how to use them. The last thing I want to leave you with is this idea of visualization. If I was able to put categories of text based on their meaning into these blobs, you'd be able to navigate through there and find the pieces you thought were most interesting or what you want to know. So if you think, I know it's hard to see, but there are lines between these. This blob up here, this light colored one, that might be what you want. And I think if those blobs were labeled, right, with text, you could put those together and find the blob that you want. And I suggest to you that's a hell of a lot easier than looking through a table, right? Or keep searching Google until you find that piece, right? So, to wrap up, what are your questions? What questions do you have? Not of me, but just of yourself. That top one would be pretty hard, right? But if you visualize it as a blob, I want the text about starting a bistro. I want to intersect it with using braised meats. I want to intersect it with the supply of local meat and produce in Sheridan, Wyoming. And I want to intersect that with the laws that have to do with raw meat in Wyoming. That might get you down to a small blob of information, right? It also could get you down to nothing, where there isn't any. But at least then you know which pieces you need to have to put together to make that happen. Okay? Something I'm a little more familiar with here at UM, how to find all the emails exchanged by professors over a 4-year academic career about, and I won't fill in that blank, but a student. Okay? And that's a pretty interesting problem because of federal law, state law, etc. So this is a pretty challenging problem. So what are your questions? That's what I leave you with. If you go away, what are your questions? What would you ask if you could ask a big mountain of text to give you back something? What would you ask? Okay, so now I'll answer a question.
Joel.
Go for it.
In terms of processing power, are you still, I mean, is this desktop or are you using servers, or what do you got to do to accomplish what you want to do with this?
We need servers, and we need to map the software solution to multiple processors. Okay. But the nice thing about this solution is once we ingest the data and map to those servers and categorize it, then we give the user back an interface, and they can start navigating through it in real time just on their desktop. So the upfront cost of analysis and doing the ingestion.
Isn't this all computer science? I mean, there's no package I can use. You've got to, don't you have to, or you're writing the software to get this done?
We are. Yeah, we started last July, and we've been writing, and we're still writing, and we're still revising and innovating. But yeah, this is from scratch. There's no package for this. Nope. What?
Do you start with the question, or do you start with the answer and work backwards?
We start with the data, and then we present it to the user to start asking questions into it. So we don't start with the answer. We start with the data organized in a way that will allow you to ask questions to get the answers.
No, but I'm figuring out how you come up with your solution for this.
Oh, how did I come up with my solution?
No, how do you work for the solution? You start with the answer and then start using the logic of it to come up with, okay, in order to get this answer, these are the questions. Or this is the way we have to ask the question.
Yes, I'm not, I mean, I would describe the process as we ingest the data and present it back to the user. And the lawyer or their legal team, they know what the issues are. So they start with those issues, which they can also categorize. And then you can map their emails, documents about the case to the evidence. And then start teasing out what the things are that you need. Does that answer your question? It's exploratory. It's not you ask the question, I'll analyze the data to meet your answer. We analyze the data up front and allow you to ask questions you might not have thought of. And we do that also because the issues in the case, when we start, may not be the same issues in the case when it's done, or when it gets to trial. You know, those things will change over time.
I'm thinking you say, okay, here's the answer to this question. How did you come to that answer? And you start working your way back. Yeah, I'm just, it's a great problem.
It's an intriguing problem.
God.
Yeah.
Are you starting with a particular corpus of information that includes things like the various definitions of the word run and the contexts around those? Or?
That's interesting. We started with a kind of dictionary thesaurus. We don't use that anymore. We look at every individual data set as unique, and we start gathering pieces of it and comparing it to each other and building up a dictionary thesaurus for that data set. We actually feel like every single data set is unique, and therefore we want to leverage the uniqueness of every data set to do that. That's a good question.
What data store are you using to house all this data?
We use a database backend to store the data after it's ingested. So MS SQL works just fine. Other questions?
It doesn't sound like you're using any traditional machine learning.
We are not. Nope. In the field now, there are traditional machine learning, predictive coding techniques. We wanted a solution that didn't require a training set. And without a training set, you can use this to do many, many more, you can solve many more problems in the legal field if you don't need a training set. That's a good question. Russ?
Are you using like a bag of words with feature selection, or how are you turning your raw text data into something the machine's processing?
That's a subject of a patent, actually. But, I mean, I've combined methods from multiple disciplines, not just computer science, but also the medical field and sociology, as well as information theory. So we're using a combination of techniques from those four fields. Sound like an evasive lawyer, don't I?
Last question, are you having fun?
I love this. It's keeping me awfully busy, but I really like it. Yep. Thank you again very much. It's been a pleasure.
Now we've got Riley Moore and Ryan Watson. And I knew that when the work that these guys were doing in Mario's class, I think I saw Mario sneak in.
He snuck in and snuck out.
Snuck in and snuck out. I knew they were up to something because it was starting to show up on my Facebook and my social media. So I'm like, I better see if we could get these guys in here and talk about what they're doing in their marketing analytics class. But again, this is another class that was created by a donor that wanted to hire employees that didn't have the skills that he could find. So he said, I want to teach this course at the university and I want Mario to teach it. I think he's been teaching it for at least 3 semesters now, maybe 4. But I'll let these guys take it away and talk about what they're learning in this class.
Okay. All right, well, I'm Ryan and this is Riley. And we're going to come at this from a little bit of a different point of view. I think a lot of the presentation that we've heard so far is what big data is and where it's going. We're going to kind of share a story with you of how we've used a big data platform to our advantage. And we're also going to share with you guys the way that we think that you guys can tell the world and some techniques that you guys can market your stories and what you guys are going to accomplish. So that's what I'm hoping that we can do with this. So let's see how this clicker works. All right, so we're going to go over how to produce engaging content and how to share and get your content to become viral. We're also going to go over goal conversions and the overall user experience of what you're trying to share with everyone. And I'll go ahead and hand it off to Riley.
Awesome, thanks. So what Eric was talking about showing up on his news feed over and over was actually our blog called Unbelievably. So about halfway through this last semester, we took everything we had been learning in marketing analytics and we decided to start a blog. So we wanted it to be something, you know, exciting, something interesting, and something a little bit unbelievable. Thanks, Becca. So what happened is our professor basically gave us free reign on everything, on content creation, on marketing it, on pushing our content, everything. So it was a little bit of a challenge. It was really exciting in a lot of parts, and it overall turned out to be an incredibly successful product. So this is our success story. Awesome. So our blog launched on March 16th, and by the end of March 17th, we already had 328 page views. So in like 24 hours, 328 page views. And then over the next 2 weeks, we increased our page views to 19,532. So in 14 days, 19,532 page views. And what's incredibly exciting is that we actually had our returning visitor rate at 16.5% after only 2 weeks. So 16.5% of that 19,000 were people who were already interested and engaged and coming back for more of our content. So now you get to know our secrets. So starting our blog, we had all sorts of ideas on how we were going to market it, how were we going to present it on social media, our Facebook page we were going to create, all of that sort of stuff. But we needed to come up with good content. So the biggest thing that's kind of exciting about having a blog in college is that there are no limits. Like our risk was basically our grade, which, sorry Mario, but there wasn't much we were going to be able to lose. So we were all about taking risks. We had content that ranged from quizzes about what Missoula beer type are you, what craft brew from Missoula are you, all the way to like a eulogy from one of the students in our class lost his best friend. So it was a very wide range of content, and we just weren't afraid to take risks with it. So you guys, the way we made that content so engaging is by having it be relevant and relatable. So what I mean by that is it was stuff that people were excited to be reading and excited to be hearing about. We had one blog post titled, you know you're from Missoula when, ... And then the content of it was just a collaboration of people's stories. You know you're from Missoula when you stand outside in the snow at Big Dipper. Things like that you can be standing here in college at Missoula and go, okay, yep, I've done that. And just be able to relate to it perfectly. So that's a huge one that we use, is just having relatable content. Now, for people who are working with big data, like Russell left, but like Russell, that's gonna look like presenting their findings in a relatable way. So for us, it was just having relatable content on our blog. And the final thing that we wish, one more background, we would have done that produces engaging content is just to throw contests. Like, people love to have ownership in things. So one thing that we're going to work on for next semester, as the blog keeps going, is throwing contests to have our users create their own content. It's free work. We just throw it into a blog post, and then people are excited to share it because it's their content. So that's what we did. If you want to go next, Ryan, this is how we measured it. So kind of like Ryan talked about, we're using Google Analytics as our platform. Behind the scenes of Google Analytics is where all of the big data happens. So this is an interface for a user to be able to look at it and analyze it. And so the three things that we decided we were going to analyze to gauge engagement were time on site, percentage of returning visitors, and pages per session. So what time on site analyzes, because we're a blog, obviously we want people to read what we're writing. So the time on site is really just our goal to compare beginning blog posts to ending blog posts about quizzes, or blog posts with quizzes to blog posts about Missoula, and all those different things, and see which ones really generate the largest time on site. So for us, our average time on site over the last 2 months has actually been 2 minutes and 59 seconds, which is completely arbitrary. The next thing that we decided to analyze was our percentage of returning visitors. So returning visitors show us engagement, obviously because they're interested. You know, it's people who are checking back daily, every other day, to see what's new on Unbelievably. What have we come up with that's crazy this time? So if you look at our 16.5% in the first 2 weeks, we actually moved that to 22.4% over the last 2 months. So 1/5 of our users are actually coming back, they're checking back in, which means we're doing something right with our content. And then the last one is pages per session. Now this is something that, depending on the type of website, the type of, basically what your goal is, this is something that's going to vary across different interfaces. So for us, our pages per session is 1.31, which is pretty low considering we want people to read our posts. So what this tells us, we actually get to use this information to change the formatting of our blog. Maybe we need to do continuous scrolling instead of making you switch through pages, things like that. So this is a piece of information that we're in the process of using to switch our blog, to hopefully increase that and to increase our time on site.
Okay, now we have kind of the basis of where we're measuring and what we can pull from our site. Now, how do we change it? And how do we share it? So the reason why our blog took off so fast and so well was the strategies that we used to share our content in unique ways. And one of the most valuable things I think that someone can take away from trying to promote, or learning from trying to promote a website, is building your true fan base. Now, a true fan is somebody who is going to share your information when you put it out on the web because they're excited about it and they're interested in it, and you want at least 1,000 of those is kind of like the perfect number for your fan base. The 80-20 rule still holds true by our data and many other studies that 80% of your content is going to be shared and promoted by only 20% of your users. Now, different platforms require different tones. So if we're trying to promote a big data initiative, we're not going to want to be snarky and sassy like our blog is. Our blog's kind of on the comedic side, more the entertainment. You want to find a medium that you can entice people to look at your information and what you're doing, or this awesome thing that you've created, or whatever is going on with this big data initiative, and entice someone to share it, and so that the next person looks at it, gets excited about it, then shares it, right? So it creates a snowball effect. Now, you want to have different tones of voice for different social media platforms. You don't want to post the same thing in Twitter that you would post in Facebook for the same content. You want to have a specific message that you want to push through Facebook, and then the same content is going to be pushed through Twitter with a different delivery, if that makes any sense. So yeah, you got to figure out your tones for each style, and with different industries, it's going to be different. With Unbelievably, our Twitter was a little bit more kind of snarky and making fun of things, whereas Facebook was like, hey, check this out, this is a really cool blog post, right? Okay, now on to viral loops. So if you notice in the first 2 weeks, our views jumped to 20,000, almost 20,000. And what really pushed that was an online quiz, which is very interesting because these days these online BuzzFeed quizzes, people are sharing their results of like, what type of plant are you? Well, I'm a ficus. That's funny. I'll share that on Facebook. And it just goes crazy viral. So when you're thinking about sharing your content or trying to figure out how that you want to get your content out in front of a lot of people, you got to think kind of you got to think out of the box. And when I created this quiz, I tried to think, who is going to share my content who I don't know and I can't say, hey, this is my blog, you should share this. I was thinking, well, Missoulians are very proud of Missoula, and they love making fun of other people in Montana. We love making fun of people from Bozeman. I mean, come on, let's face it. And people from Butte, people from California. So I thought, well, how am I going to do this? So I made this online personality quiz that people would take the quiz, and then this would come up. So when I took the quiz, this is what came up for me. I got the true local, because I'm a local kid, I'm from Missoula. And it has this little, bio of who you are because you're from Missoula, and it just kind of seemed super cool. And if I hadn't seen this blog, I totally would have shared this. And as you can see right down here, we got 1,500 people to share this quiz. And then from then, it hit 6,000 people in the first 3 days that it was live. Because of this snowball effect of the share result and how it just spread across the Facebook social media platform, it increased our page views a lot. And as you can see here, here's our this is our overall data, our data overall from the beginning of middle of March up until today. You can see that Facebook mobile referred us over 10,000 times, and then from desktops referred us about 9,000 times, which is incredible. And that's partially due to just the viralness of our post and how well it's shared on Facebook. So that's that. And then, as you can see here, here's another bit of information that can show you our social is 73.5% of all of our views is coming from social. Okay, and then hand it off to Riley.
Perfect, thanks. So after we had that initial spike in views, it was super exciting, and we were throwing a little party in our classroom, but it's kind of meaningless because we didn't know how we got there. So it doesn't really mean much if you can sit and watch your page views, or you can sit and watch how many people are looking at your data that you're presenting. Doesn't really mean much unless you have it put into kind of a goal. So what we did, we decided we needed a couple goals to really help us understand what was going on our website page. So we set up 2 different goals. We set up email subscribers as well as time on site. Our email subscriber one was kind of a flop, but it was a great learning experience. We learned that we weren't getting quite as many email subscribers as we would have liked to have, which again indicates that we just need to kind of give value if we want people to give us some of their information. And so that's a good marketing-wise, data-wise lesson, is always provide value if you're asking for something. So maybe a free ebook or something of that sort. Through our goal conversion, we learned that we were not meeting our goal for email subscribers. But for our goal of time on session, we decided that 3 minutes is probably long enough for somebody to read the average blog post. And because we don't have ads on our site, we don't have it monetized in any way, we kind of had to give it an arbitrary monetization. So we gave it 25 cents per conversion. So for every time somebody was on our site for 3 minutes, we got 25 cents to kind of show us how we could monetize our site. So if you see, we got 1,111 goal conversions since April 6th when we decided to start implementing this. So what that tells us, if we had monetized our site for 25 cents for every 3 minutes someone had been on our site, we would have made $278 since April 5th. So it's just kind of a good way to assign value and see if the things you're going for are actually happening, if you're actually hitting your goals. Now, this doesn't necessarily mean that your goal should be time on site. It depends what you're trying to get across. If you are using cost per 1,000 views advertising, and you get paid for every 1,000 people that see this ad, maybe you need to focus more on page views. Or if you're trying to present your data and it's more important for you to have eyes on your data, maybe you need to focus more on visits instead of your conversion rates that way. So for us, it was just time on site.
Okay, now it's all about the user experience these days and making sure that people stay on your site or actually interact with your site and produce the conversions that you desire. So what we found in Google Analytics is that mobile was the majority of our data. It was 50.99%, and desktop is at 42.727%, and tablet data was 6.75%, which is more and more becoming more common with the use of mobile phones, iPads. So you need to make sure that your mobile experience is simple easy and user-friendly so that people have positive web experiences with your online content. So you have to make sure that your site is what's called responsive. So when you look at it on a phone, you can see all of the data without having to scroll out and shrink in to find what you're looking for. It presents itself in a logical manner. And when you open it up on a web page, it presents well as well. So when you have responsive code, it makes for an overall, just a better experience for the user. Now, when you do that, it also, kind of removes the whole awkwardness of when you have to like shrink your browser, and you're trying to open up two browsers, 2 pages, look at them at the same time, watch a movie at the same time as you're working on something. It just ensures that it's easy to view the information on your site. Okay, and in conclusion, just kind of wanted to go over a little bit of the metrics here so you guys can get a big picture of what happened over the course of these last 2 months. So we had a total of 31,000 people look at our site, 41,000 page views, which is incredible for that short amount of time. And we had a 22.5% returning visitor rate, which was awesome. And yeah, what I would encourage you guys to do is, take risks, push the limits a little bit, and make stuff happen, because it's amazing what you can do with your viral content.
Thanks.
Any questions?
Are you going to be able to get somebody to work on it over the summer? I saw that was to kind of keep it going for next semester.
The class was so amped about this that I think that we're just going to.
People are just going to post blogs over the summer.
So.
I'm sorry, but tell me again the URL, and also what platform are you on? Do you have someone coding this website for you? Are you on Squarespace? Are you on WordPress? Those are all popular.
Good question. We're actually on WordPress. So we do our analytics through Google Analytics, and we put their little piece of code onto our WordPress, and they track everything. They track every single time someone logs into our blog. They give them a little cookie. They track when they log out, how long they're on, everything like that for us. So all those pieces of big data are behind our Google Analytics platform that we've been using to analyze.
And our URL was unbelievable.ly. So it's a Libyan URL.
It's unbelievably.
What are your majors?
Marketing. We're both marketing majors.
Both marketing. How do you think you're going to use this experience when you leave school?
Oh gosh. I believe that in the marketing world, especially now, especially with this big data initiative, being able to read analytics and make a story out of analytics is just going to be incredible. And being able to do that through our blog. Every single one of us in the class had access to the analytics, and we could go through it kind of as our story was progressing. And I think being able to have that skill right there is going to help me so much more. Be a little bit of a step ahead.
I think that, to answer the same question on my end, that when you're a marketer, especially back in the day, it was really hard to make sure that your marketing was actually making the sale happen. Now with this, we can prove that people are converting. Once they hit our site, they navigate. We can track how they navigate to the point of sale immediately, and you can measure the results. You can measure your shares on Facebook, so you can see that, oh, Facebook referrals are driving more people to, buying our product, or donating money to our nonprofit, right? So I think that what this process is going to allow us to do is be able to show a firm that I'm applying for is like, I know how to show you that my work is actually producing results.
I would concur. I think whether it's marketing or whatever profession you're in, it's becoming more and more clear that if you don't have a basics in data analytics, it's going to be more and more difficult to survive.
Absolutely.
I agree.
Just hang on.
Did you trace how people found your site?
We did.
Where they came from, and what is it a keyword that really worked for you, or what?
We did. The majority, kind of what Ryan showed, I don't know if you want to click back to it or not, that chart that Ryan showed, one more, is where most of our traffic was coming from. So this is what shows that 35% was coming from mobile Facebook, 29% was coming from desktop Facebook, and 24% was actually coming from direct, so people typing unbelievably into the bar on top. And then the rest of it, so we got like 500 from Reddit, things like that. We tried some crazy things. We actually got a zombie hunting website to link to us for our zombie apocalypse blog. So that's kind of how we traced where people were coming from.
And was it typing the word unbelievably? Is that what got them there?
Typing the word unbelievably is for 24%.
So what that's called is like organic search.
Yeah.
Organic search could be when you pull a link to your favorites bar and you click on that. Every time you click on that, that's an organic search result. So that's what that is as well.
And also down here on Google. So this is if they're searching it and putting it like into where you would type www.unbelievably. This is for when, so 222 found it on Google. So for the most part, people were typing it straight into the URL bar.
Yeah, we had, I was doing it for like a week. I would take, for those of you who know what Snapchat is, I would make my Snapchat story say just the URL unbelievably, so when people would look at it, what's that? And type it into the computer. Trying to get more
some
views.
crazy marketing tactics.
Did you drill down those organic search results to determine what keywords were successful and which ones weren't?
We definitely haven't yet. Mario has talked to us about next semester diving more into search engine optimization and looking at more data like that. I think just because of how unexpectedly it exploded, Mario wasn't even expecting that we would get much organic search results. But definitely for next semester in his class, we're definitely going to take a look at that.
What kind of hurdles did you guys face as a class to really, make sure everyone, because for results that great, it does require a lot of time and effort put in by everyone. Was there any hurdles that you guys faced as far as getting people to actually really hop on board with it, or?
Well, as a part of our grade, we actually each have to do 3 blog posts. So it wasn't super hard to get people to do the blog posts. I would say everybody was pretty excited about it. Everybody in our class was pretty jacked about the opportunity to post. One of the biggest hurdles I think we ran into was social media was like our greatest friend and also our biggest enemy, and the fact that some of our stuff shared fantastically. Our quizzes, the things about Missoula, things like that were wonderful. But there were a couple of more behind the scene things. We had a great photojournalism blog that just didn't quite get the shares that it probably deserved. So that was one of our big hurdles, is figuring out how to market those specific blogs in a way that people want to share them.
So instead of social media, do a link out to another blog or something.
Exactly, targeting more specifically instead of just so focused on social media.
The strategies we used for that was kind of seeing what would happen. I mean, I tweeted at 20 zombie Twitter accounts, and one of them linked back to us. So it definitely does work.
And it is a little bit more work.
I think some challenges too is even the title of your content could be the factor that makes it a successful blog post or not. So having a title that's enticing, but as soon as they want to click on it because of the title, but then they look at it, it's like, oh, it's not the content I was looking for, it might get you a super high bounce rate, right? Or, the title is just boring and they don't click on it. Any other questions?
Thanks a lot, guys.
Thanks.
And yes, we are having fun.
Yeah, check out our blog and subscribe to it.
Yes, subscribe to it.
So John Clutchin from biology is going to be our last presenter. And when I went over, I think that, at least I think a lot of you are probably seeing, I hope, a theme in this, and that basically we're trying to sort through data no matter what the field is, and we're all running into different problems. So I thought it was interesting to go over to biology and sit down with John and kind of have the same discussions of problems. He's using Python to look through data. We're looking at using Python in a new data analytics class for the business school to teach our students how to work through data. So even though very different sides of campus, I guess I could put it, we're all looking at kind of the same problems. And I know John also has a class that he'll talk about programming for genomics that he's introduced, so these students can solve those similar data problems that they're running into. So it's yours.
Yeah, thanks. This is a unique opportunity. don't think I've ever talked to a business department before. So here goes. I want to give an overview of what we do and the sort of problems that we run into with the size of data. And I'll talk about the particular data sets that we run into. But I want to make it clear that this is just my perspective. Biologists, probably like most fields, are sort of independent, and this is just me, not all biologists. So what we do, in summary, is sequence and analyze genomes. So I'm not going to go into it too much, but your genome is the DNA blueprint that makes you you and makes any organism it. So you probably have heard about this, but sequencing DNA, making new sequence, or generating the sequence, is really cheap. So this is a figure. It actually ends in October of 11, so it's old, but the point is still valid. That for a while, for several years, the cost of generating a certain amount of sequence followed Moore's law, which is this famous law from Gordon Moore, which says that the power of computers double every 18 months or something like that. And it fell off. It actually sort of increased, the sequencing got cheaper, and about 2007 sort of fell off that scale. And this is a really interesting time in biology. About October 2007 is when biology didn't really enter the big data because the data sets were large before this. But what happened is that sequencing, the ability to generate enormous data sets, was democratized. So at the University of Montana, for example, we have instruments now that can generate really large data sets in just, my lab, my little tiny lab can do this now. So it's democratized. It isn't just these big centers. So the details here are obviously not that important, but I just want to give you a sense of what I mean when I mean big and the sort of increase that's happened in the last few years. So this is a certain type of sequencing platform called Illumina. It doesn't really matter. But the output of these machines is shown down here. So that's 15 gigabases out to about 1.6, 1.7 terabases. So a gig is 10 to the 9th. It's a billion base pairs of DNA. A terabyte is a trillion base pairs of DNA. So just for reference, our genome, the human genome, is about 3 gigabases, 3 times 10 to the 9th, or 3 billion base pairs. And a new machine from this company can sequence about 30 genomes in 3 days for about $1,000 each. Just to give you a sense of that, the first Human Genome Project, the one where Bill Clinton and various people stood up and said we've sequenced the human genome, took about 10 years, cost $2.7 billion, and generated about 23 gigs of data. So we can generate, here at the University of Montana, in 3 days, we can generate more data than was generated by the entire Human Genome Project in 10 years. So that's the sort of scale we work at now. And for the most part, we know what to do with this stuff. I mean, we don't generate it and then hope to find something. We have a hypothesis that we test. So this is a snapshot just showing you about 2,500 base pairs of a genome. It doesn't matter which genome it is. So that's about 0.0000083% of the human genome. So a small amount. And so what we do, the details aren't really important, but it's kind of interesting. Just from technological limitations, what we do is we take a perfectly good human genome, for example, we break it up into small pieces, we sequence those small pieces, and then we try to build this thing back together to recapitulate the genome that we broke up. And the reason we do that is technological. We just can't sequence long bits. But this is a representation of that. So this is, across the top here is 2.5 kilobases of sequence, and each one of these lines is a little read we've generated from one of these machines, and you can see that's, probably can't see actually, that's a G, that's a C, that's a T, that's a T, that's a T. There's 4 bases in DNA, and this is what we do on the computer. So we take DNA, we break it up, we sequence it, we try to put it back together, and then we try to study it. And so we know what we're looking for, right? We're interested, our lab is interested in how genomes evolve in response to certain things. But what we struggle with are basically 2 things. For lack of a better verb, wrangling the data. It produces a lot in different formats, and we have to deal with that. And it probably goes without saying it doesn't really fit in Excel. The other problem, the one that's most interesting to me, is how you look at it, how you visualize this stuff. And so we ask questions like, how do you efficiently show how two genomes are related to each other? So in the top left, there's a green genome, it doesn't matter, and an orange genome, and they have some structure and they share they have some relationship to one another. You can see by the way the lines are drawn. Or this is a paper that actually we just submitted this morning, the graduate student JT Van Leuven that was working on it. So how do we encapsulate really terabytes of data that we've generated over 3 genome projects, which are shown in orange, green, and blue, in a way that clearly illustrates our point? So this is the kind of problem we have, and this stuff is really interesting to me. And so I thought I would I know it's late, and I appreciate you pretending to listen, but I'll walk you through sort of one case study to give you a sense of the kind of questions we're asking. It won't be long, and then I'll just sort of go through what we've done in the class to work on this and see if there's any overlap in people's interests. So this is some work that was just published a few months ago from Amanda Brown. She was the postdoc that was working on this. So this was done in my lab, Amanda, and then 2 undergraduates, Caitlin and Kelly, and me. And so this is work supported by the United States Department of Agriculture to study the evolution of an invasive insect that was just introduced into the Southeast in 2009. And so this insect was introduced from Japan, we think, and it's a problem, it turns out, because it feeds on not only kudzu, its native plant, which is invasive itself in the Southeast, but it also feeds on soybeans. And this is a big problem because soybeans are around about a $40 billion crop in the southeastern United States, and stink bugs, this invasive pest, really, really decreases the output of soybean plants. So this is a really big problem. So we had the opportunity to study this insect from the beginning. As I said, this was introduced in 2009. And we knew a few things. This is a picture of the insect. It's called a stink bug. There's 2 species, maybe you've heard of it. This is it. So there's a bacterium that lives in this insect's gut. This is the kind of stuff we're interested in. There's a bacterium that lives in an insect's gut. And we know that this bacterium is required by the insect. So if the bacteria is not there, or if it's cured in some way, the insect dies. It can't survive on the plant without the bacteria. So we were interested in studying, so we knew that. We knew that there was an important difference in these insects, and it was related to nutrition. Kudzu and soy are different nutritionally, the stuff that this insect eats. And we can see very clearly these are the exact same genotype, same species of insect. On the top are from a soybean field, on the bottom are from a kudzu plant. So we knew there was some nutritional difference. We knew it wasn't related to the genotype of the insect. And so we were very interested in studying this bacterium, again, which lives inside the gut of the insect. And the reason the USDA was interested, because if you don't have the bacteria, you don't have the insect. So what we did was we do this genomics thing. We just sequenced till the cows come home, essentially. What we did was we had access to, this is where the invasion started, here near Atlanta and Athens, Georgia. In 2009, it's dark, and as the colors get lighter, this is how the insect has spread over the last 2 or 3, maybe 3 or 4 years now. And so we sampled from across the range in space and in time and sequenced the genome, many genomes, 48, I can't remember what the number is now, it's about 60 genomes of this bacteria living in the gut of this insect across its range. And so we have a problem. And this is the problem that Amanda solved after much work, is looking at this stuff, right? So imagine we have 50 data sets, each one is 700,000 times the depth, so each one's about a gigabase or so. And you want to look at these and figure out what the data are telling you. It's not easy, and this may not be easy to understand, but it actually is for biologists, and people complimented us on this figure. If you look at this for a cup of coffee, you can see that the evolution of the riboflavin pathways, so the genome evolution of this bacterium has actually changed on the 2 host plants. So we can, and riboflavin is a nutritional, it's a vitamin basically that the insect needs. So we could see differences in the way the riboflavin pathway was evolving in this bacterium across the host range of the insect from which we sequence. But we had a problem here, right? As I said, we have about 40 different data sets, each one comprising several gigabases of data, and a genome that is about 700,000 base pairs long. We needed to look at it. And so these are the kind of solutions we come up with. But from my perspective, the real problem in biology, and the thing that, or it's a problem in genomics especially, this field, and I think maybe it's a problem generally, in my view of this, is that if you look at problems in new ways, if you solve problems in new ways in genomics or probably any other field, you will produce, in this case, big-ish, whatever, data sets that software can't handle. This is sort of our motto. This is what we run up against all the time. And so this was a problem for me in a number of ways. This is a neat thing to solve, number one. Number two, I like to have undergraduates work in the lab. I like to have graduate students work in the lab, but none of them could do this. So I convinced my chair to teach a class called Programming for Genomics, which is a terrible title, but that's what I called it, to teach these skills to biology students. So we were working under the idea that, and I think this is true, as you've seen today, this evening, is that students, modern students of biology, or indeed chemistry, or indeed art, or indeed business, need to know how to do a couple of different things. They need to know, number one, how to wrangle big data sets. Again, you can't just plug things in to Excel. You need a general purpose programming language. And I think we need the ability to visualize things in a way that, again, aren't canned. You can't just plug these data into something and then look at it. I mean, pie charts are fine, but they don't do anything for these kind of data sets. And so what I like to think about is going from the whiteboard to the computer. So if we can get out and sketch, what would the perfect figure look like? To show all these data, we need to be able to go into the computer and wrangle that data and then draw it. And so to do that, we need a general purpose sketching language, something like processing, which maybe you've heard about or maybe you haven't. In my class, we took two approaches. We used Python as our general purpose language, and we used processing as our visualization language. And so what I wanted to do in this class was, again, to take students, it ended up being about half undergraduates and half graduate students, and take them with no programming experience and give them these tools. So with no prior training, teach them how to deal with these data in a general purpose language for just text manipulations, text matching, string matching, and then drawing sketches that they created with processing. And so a typical assignment from a few weeks ago was to do this. This is just part of the output from one of those machines that I was showing you, those Illumina machines. Here's a file with 48 million lines that look like this. I want you to show me, I want you to take these data, massage it in a way that makes sense to you, that you can visualize, and draw the output of this file on the computer and show me where the data quality are bad. And so you should expect an answer that is a long, skinny row for technical reasons, because that's what the plate looks like that does the sequencing. And so this is what it looks like when undergraduates gain these skills, the ability to manage these huge data sets and then visualize them. This is Caitlin Carey. She's a senior in biochemistry at DBS, a budding Python and processing programmer. And this is Kristen Cook. It's really dark, but she's a postbac in wildlife, so different backgrounds, also really talented programmers, it turns out. And so what you're looking at here is a representation of the quality of the data across this space from this sequencing machine. And in Kristen's example, low quality is red. And in Caitlin's example, low quality is dark. So you can see there's a very strong edge effect here of low quality data. And this is actually now something that we're implementing in the lab as a routine thing when this data comes off the machine, is the stuff that Kristen and Caitlin have put together. So it's really useful, powerful stuff that these students are able to do. And just to show you sort of one more picture, this is something that, oh, the colors are terrible. This is something that Tom Brecky, a graduate student who's also in the class, has been doing to look at his genomic data. You can just trust me, there's a lot going in here. This is a expression in 2 different hamsters and different crosses across the length of the gene there's various things, but there's several gigabases of sequence information in this figure, and you can look at it and in a second get a sense of what it is. So Tom took an idea, he sketched it, and then he drew it on the computer in processing. So I've tried to go fast because it's almost 7:30, but I'm especially interested in using programming languages to sketch things. And so I know people are, at least in my department in DBS and in the School of Art, processing is actually taught, programming language is taught in the School of Art because this was a language invented for visual artists. And I know Python's taught by us, it's taught, I'm sure, all over the place, math or CS or maybe business too. So if you want to talk more, that's my email address. That's the kind of stuff I'm interested in. And I appreciate you taking the time at 7:30 in the evening. That's it.
How did you find that students, how receptive were they without a programming background to Python?
Yeah, so I don't know. So teaching people programming, and so basically the answer is half of them liked it, and half of them put up with it. I think it's a clear language. It's clear as any other, and for a general purpose language, it's good. But some of them really love the visualization part of processing. So processing is basically it's a language. It's based on Java, but I don't want to get too far in the weeds here. But there's basically 7 structures you can draw with, and it has all the for loops, and it has the control structures, the simple data structures that you need. But you can, if you really want to understand how a for loop works, it turns out it's really cool to draw something with it. So a lot of them responded to that. It's much more visual than just a text output. It's more fun to interact with, I think. So it was actually nice to teach both languages at the same time.
I really like your term wrangling, because to me that's, the big data, you got to get in a form you can do analytics on it. And it's coming at you in all different texts and all different formats. That's what I'm going to ask Joel too. You got to get the computer science to get in a form, and then you can start analyzing it.
Yeah.
And we had one speaker that said 80% of the job is the computer science part of it.
And I think it's true in my field in biology too. It's 80% is wrangling, numerical prestidigitation. This is what one person called it. I think what we should think more about is, I'm sure Joel will be happy to hear this. I think everyone should take programming language. I think just every student, I think it should be part of the curriculum in college. And the reasons are obvious. It doesn't matter what your field is. I think wrangling, Joel's presentation said it clearly. It's everywhere. It's inevitable. It's only going to get worse. You need to know how to deal with it if you want to be a productive member of society.
College or high school?
You can't start too early. It's fun. I mean, you can start too early. My 6-year-old is too young. But we have a Raspberry Pi.
Who started their own programming companies and made a lot of money.
Yeah. No, maybe he likes hockey more than. But yeah, it's fine. I don't think you can start too early. I just started programming in BASIC when I was in grade school too. So, certainly by college, it's not too late. I mean, these are all seniors and they're well on their way. So.
How many of them had done programming before?
1.
Out of how many?
19.
Wow.
Any other questions?
Okay, thanks.
All right, well, thanks a lot.